All right, here's our review video. I'm probably going to talk pretty quickly because I'm running out of time, but I'll do my best to give you some good tips for tomorrow. So the whole first part is finding the value that completes the square. I think you all were pretty good at this. Remember, we take the middle number and cut it in half. So that's going to be, on this first one, 9. So I've got z plus 9 squared because we're completing s square. And then our final blank comes from that number times itself. So notice that you've written here 9 times 9, or 9 squared. So 9 times 9 is 81. Number 4 is very similar. Split 22 in half and you get m plus 11 squared. And then 11 times 11 is 121. Now 2 and 3 are a little bit different because they have a number in the front. Remember that number, we have to treat it as the GCF. And then we have to divide our problem by that number. Remember, I rewrite that as a blank. So I rewrite it to a simpler problem, and now I'm back to that basic problem like I had before. X minus 3 squared, 3 times 3 is 9. Now the difference here with GCF is that you've got to take this GCF and put it in 2 places. One is in the very front of your factors to be your final parenthesis there, and also you have to multiply it by your final number, which is going to leave a final number of 27 for question number 2. 3 actually does have a GCF. Don't get tricked there. The GCF is going to be -1. So a GCF is -1. Then my factor, or my problem, becomes x squared minus 12x plus blank. When I cut that in half, I get -6. So that's going to give me x minus 6 squared, 36 in this blank. And then again, I've got to bring my GCF into 2 places. 1 goes to the very front, so that's -1. And then -1 times 36 is -36 is the value that goes in the blank. All right, notice this page tells you to factor. You are going to have to do factoring and roots tomorrow, but it's going to be very clear which is which. The directions only say to factor, but I will add in roots just so that you get some extra practice with that. All right, so on question 5 here, notice that on question 5, there is x to the 3rd, which generally means you're going to have a GCF with a variable in it. And also, there's a 2 I can divide by all of those. So I have GCF is going to be 2a. When I divide that, that gives me a squared minus 4a minus 5. Now I'm to a normal problem. I'm trying to pick my 2 numbers that multiply to give me -5. Add to give me -4, and that's going to be -5 and +1. Remember, those numbers, all of that, you just have to be able to pick on your own. Can't really do much for you there. So then we've got a minus 5 and a plus 1. Ooh, a. Then we don't need to divide by anything. All we have left to do is bring this GCF down. So we have 2a in the front here. Now the thing that is not listed here that you probably need to practice is roots. So remember, roots are going to come from each of these. When the a stands alone, like it does here, the root is 0. So that's 0, 0. In the middle here, we've got a root of 5, 0. And at the end, remember, roots are opposite, -1, 0. Okay, let's look at question 6. Question 6 is missing the middle. So this is an example of conjugates or difference of squares. So you could work this out, but the easiest thing to do is just set up your 2 parentheses. One's positive, one's negative. Think about how you split v squared apart. That's 2v and 2v. And then how you split -1 apart. Sometimes that tricks people. That's +1 and -1. All right. Now, if we're going to say your roots, notice that since these have a number in the front, that means each of your roots is going to be a fraction. And that number, originally, think about it, it had come up from the bottom. So the original fraction would have been 1/2. So my first root is -1/2, 0. And my second is 1/2, 0. All right, let's look at question 7. And I notice here that I have a GCF. There's a number I can divide all of those by, and that's the number 2. So the GCF does not always, when you factor, match that first number. So I've got a GCF of 2, which is going to give me 25x squared minus 10x plus 1 when I divide. And now this 25 is no longer a GCF, so I've got to move it to the end. Remember, the arrow is going to help you not forget something later. So x squared minus 10x plus 25. So now I'm trying to come up with two numbers that multiply to give me 25 and add to give me negative 10. And those two numbers are going to be negative 5 and negative 5. So x minus 5. So here is where we said, that's why I'm saying that arrow is helpful, because we have to remember to go back and divide by this 25, which neither of those divide, but they do simplify, which is going to give me x minus 1/5, x plus 1/5. Some of you have learned that this is a quick step to find your roots. It's easy to see them right here. So your roots are going to be positive 1/5, 0, and negative 1/5, 0. However, you have to, if you're factoring, you actually still have to fix this. So remember, this bottom needs to come up because it's stuck there. So I've got 5x minus 1, 5x. Oh, and I have a sign error. That should be a minus 1. Minus 1. That's going to be positive. Minus 1. Man, I'm struggling. All right, and then what I had told you in the video is that there is the simplest way to write this is to write that as 5x minus 1 squared, but don't forget this GCF of 2 needs to be in the front of your answer. All right, you may need to watch that example again and pardon my errors, my sign errors. Question 8. I did this for some of you in third period, but for everybody else, let's just make sure we're on the same page. I cannot divide 3 by all of those numbers, but I can take a b out. So my GCF is going to be b. That gives me 3b squared minus 25b minus 18. Now I can move this number to the end. That's negative 54. And I'm looking for negative 25. Sorry, I'm skipping steps here. 25b minus 54. So my two numbers then are going to be negative 27 and positive 2, b minus 27, b plus 2. And then because I moved the 3 to the end, I've got to divide it so that I can bring it back up. That's going to give me b, minus 9. 2/3 does not simplify, so that's 3b plus 2. Remember, my GCF is going to come down to be b, so that's my factor. And then if I want to name my roots, there should be 3 this time because there's 3 places that I see variables. So my first root is going to be 0, 0, anytime you've got a variable by itself. My second root is going to be 9, 0. And my last root is going to be negative 2/3, 0. All right, question 9 here. This should look like conjugates to you, except you should see a problem, and the problem is that you can't split 18 or 50 into numbers that will multiply by themselves. So the first thing is we actually have to do a GCF here. That should always be your first step on every problem. So I can take out a GCF of 2, which leaves me with 9b squared minus 25, and those are numbers that I like a lot better. So that's going to give me 3b and 3b. And then negative 25 will be plus 5 minus 5. GCF comes down. And then we have a root for every variable that you see. So there's a root here, negative 5 over 3, comma 0. And here is positive 5 over 3, comma 0. Remember, that's over 3 because this 3 would have been coming up from the bottom. All right, in question 10 here, again, we need to start with a GCF. Notice that you should always start with that if that's possible. So my GCF is going to be 4, which is going to give me the problem, 16p squared plus 8p plus 1. Now I'm ready to move this to the end, p squared plus 8p plus 16. So two numbers that multiply to 16 and add to give me 8. Those are 4 and 4. So p plus 4, p plus 4. And then I've got to bring that 16 back. That does simplify to 1/4, so p plus 1/4, p plus 1/4. And now bottoms up. So remember to bring the bottom to the front. So that's 4p plus 1. Notice both of these will be the same thing, so I'm going to kind of shortcut it and go ahead and put the squared right here. And then I also have my GCF at the front, which is 4. And then when I go to name my roots, remember I can use the fraction. That may be a little easier. My roots are going to be negative 1/4, comma 0, and negative 1/4, comma 0. And I know it seems silly to list that twice, but we'll talk about a little bit more next week, kind of why we do that and what that really means. All right, I am going to do the odd problems, 11, 13, 15, and 17, just so that you see them, because you are going to need to know how to do those. If not tomorrow, you at least need to know how to do them, though I think you are going to see at least some of this on your test tomorrow. So in 11, they're telling me to write vertex form. That means I have to assume that this last number is going to be wrong. So that gives me negative 2x squared minus 4x plus blank. And then I can do a GCF there of negative 2. So that's x squared plus 2x plus blank. When I cut in half, I get x plus 1 squared. And 1 squared is going to give me, so now I've broken it all the way down, so I'm going to start working back up. 1 times 1 gives me 1. My GCF goes in 2 places, negative 2, and at the end. So that's going to give me negative 2 here. And then I have to fix the wrong number. That's the last thing I have to do. And to fix that, I could add 9. So I'm going to add 9 to my final answer. So my answer is y equals negative 2, parentheses, x plus 2 squared plus 9. And just for practice, now that we've got that answer, you probably need to take these two equations like we did in class today and just try to remember, how did we get all of the information for question 12? That's a skill that is going to be important coming up. All right, question 13. This is I don't know why they are saying this. This should not say intercept form. That should say factored form. I forgot to change that for you all. So to write in factored form, you all know how to do factors. I need to pick two numbers that multiply to give me 14 and add to give me 9. Those numbers are going to be 7 and 2. So this is going to be y equals x plus 7 and x plus 2. There's really no other mystery there. That is the final answer. All right, now that you've got that, I really would recommend that you take both of these equations and try to answer as many of these parts to question 14 as you can make sense of. You should be able to get most of them, if not all of them. Question 15 here is asking me to move into standard form. Remember, standard is the one that gives us our y-intercept, our ax squared plus bx plus c. Most of this we did last week, so this is just a review of that. X plus 6 squared, so we're going to do the parentheses part first. And I have to double distribute, so that's x squared plus 6x plus 6x plus 36. If there was a number in front of this, we would bring that down to multiply, but there isn't, so we can just leave that there. I do need to bring down my plus 9. And now I'm just going to combine like terms. That means 6x here in the middle and 36 plus 9 at the end. So I've got y equals x squared plus 12x plus, let's see, what is that, 45. Now you need to, even though I'm not doing any of these even problems, you really probably should try to answer as many of those questions as you can based on these two equations. It's really going to help you prepare for your state test coming up next week. All right, and our last problem is going to be 17 here. Again, they're telling me to write the standard form, and this is easy again because there's no number in the front, so we're going to distribute first. Y equals x squared minus 4x minus 8x plus 32. If there was a number in the front, that's when you would bring it down to distribute to everything. But since there's not, we're ready to combine like terms. So my final answer here is going to be y equals x squared minus 12x plus 32. Again, I encourage you to use these two equations to try to answer as many parts as you can of question 18.